Okay guys, welcome back. Sorry it took me so long to get this lecture posted. I'm not going to lie, I have screwed up this lecture probably 15 times. These operators, this is probably the most confusing hump in learning C++, and I've heard this from several different YouTube videos. This is confusing. I'm going to do my absolute best to make this as clear as humanly possible. Please bear with me. I got my little notepad here. I've got it organized. I might still mess up though. This is a tricky one. So, under operators, you have four types. Arithmetic, which is your basic math operators. Assignment, comparison, logical, and bitwise. I'm actually going to break this down into two separate lectures, actually. That way I can practice the second part again. Arithmetic, that's pretty easy. You have addition, just adds two numbers, x plus y. Subtraction, x minus y. Multiplication, x times y. X divided by y. This one's a little bit confusing. This one might throw you off. This gives you the remainder. So in other words, if you have 10 divided by 9, you'd have the answer of 1 with a remainder of 1. And this one here just increases the value of whatever x is by 1, and this one decreases the value of whatever x is by 1. So when you're programming, you might dim x as 5 or declare x as as the number 5, and later on, for whatever reason, in your program, depending on what you're doing, maybe it's a score counter for a video game. You need to add 1 every time something happens. So you could use the increment, or you could keep doing x plus 1 every time it happens, or you could use the increment operator, and then you could reuse the same function over and over again, and that will make sense later on when I say that you could use the same function over and over. So basically, let's go ahead and try them, because I don't want to move too fast and lose people. Bear with me, and if you zone out, just pause the video and take a break. I've had to do it countless times through this part, and that's of course going to happen. Don't do that to me now. This is the 20th time. Come on. It's going to go. Okay. Which one are we on? We're on addition. 5 plus 3, x equals 5, y equals 3, x plus y. C out is going to be 8. 5 plus 3 equals 8. So that one's pretty easy. Subtraction, it's going to look just the same. Only it's just going to subtract the two values. So 5 minus 3 equals 2, and maybe I change this to 9 minus 3 is going to give us a 6. Simple math. And of course, we still have our include input-output stream using the standard library. And then we have our function, which is 9 is being declared as an integer, 3 is being declared as an integer, and C out is going to be 9 minus 3, which is 6. So that all makes perfect sense. I'll go over. I might as well go through them. I don't want to leave any stone uncovered on this module. But it would be nice if it would go faster. Okay. So 5 times 3, x is 5, y is 3, we get 15. And you know what? I will skip division, because I think you guys have the point by now. Now this one's a little bit confusing. It returns the remainder. So if we have 9 divided by, well, let's just do 10 divided by 9. You'd have 1 with a remainder of 1, and what you're going to see is the remainder of 1. That's what the output's going to be. So 5 divided by 2 equals 2 with a remainder of 1. Because 2 times 2 is 4, so you have 1 more left to get to 5. I know remainders might have been a long time for you guys, but that's what that means. And let's try the example I gave. I said 10 divided by 9 would be 1 with a remainder of 1. There it is. Okay. Increment. Like I said, this would be great for a score counter. 5, we're just incrementing it by 1. Put an 8 in there, it'll turn it into a 9. There it is, there's your 9. And decrement, same thing, it just decreases the variable. I'll just show you the code real quick. We won't change anything because it is taking a while to load for some reason. 5, take away 1, you've got 4. And that's what this operator does. Okay, if you are not feeling energetic mentally, well, this is easy enough. You multiply these two things. We're just going to put in, trust me, this is right. 10 times 5, it'll give you 50 if I submit the answer. If you're not feeling mentally energetic right now, take a break. I won't dock late points on this one as long as you don't take too terribly long on it. I know I'm late getting the lecture up. This was a tough one to figure out well enough to actually be able to explain it to some extent. So, here we go. An assignment operator just assigns a value to a variable. So, the equals one we've been using all the time. We just didn't really understand that it was an assignment operator at that time. It wasn't explained yet, but it just seems kind of common sense. X equals 10. Okay, that's easy enough. The addition assignment operator adds a value to a variable. So this is saying that x. So up here somewhere, x was declared as a 5. So, the variable x is 5, but now we're saying that we want the variable, well, I should have said it this way. Let's just, x is declared as a 10. The variable x is 10, but now we want that variable plus 5. So your answer is going to be 15. You're saying x, which is 10, we're going to add another 5 to it. It's not equal to, we want to add it to, then see what it equals. So there's another way to write this. Yeah, so 15. 10 plus 5 equals 15. This would be the same as saying x equals 10 plus 5. It's really that simple, but this can come in handy. This could come in very handy if this is the result of a function. So when you start building things off of things, these operators can become useful. Right now you just need to understand that this just means 10 plus 5. X is now going to equal 10 plus 5. It's actually the variable plus another 5 is now the variable. Okay, now they give us some explanation on these ones, but then they leave us to guess what all these are, and this is where things got really dicey. Before I dive into this, we need to understand binary code. I know a lot of you probably already have a pretty good idea on binary code, but when we get into the bitwise operators, these are actually breaking down your variables into binary code and then running functions off of them. So if you don't understand how to break a 3 down, so a 3 would be a 0, 0, 1, 1, and I will explain that right now. Where was that? That is, start with this one. I'm going to change the name out of this because this is actually an old high school Blizzard bag. And I'll submit this as a practice assignment for you guys. I don't think I'll take this as a grade, but it would be a very good idea to do this if you've never used binary before. So the best way to explain this is, I like to explain it as being tally marks. Your binary code, 0, 0, 1, 1, the very first digit, the very first one, would be a tally mark under the ones place. The very second digit would be a tally mark under the 2's place. So let's just look at 0011. That would be a binary 3. It is right here because you got a 2 and a 1. So if you had I didn't give you guys, oh, here it is. This would be a binary 1 because there is a tally mark underneath only the 1. A binary 2 would be a tally mark under only the 2. A binary 3, you would need a 2 plus a 1. A binary 4, you would need, I guess I didn't do a 4, but you would just need a hash mark under the 4. A 5, you would need a 4 and a 1. A 6, a 4 and a 2. A 7, you would need all 3, a 4, 2, and a 1. And for a 16, 8 plus 4 plus 2 plus 1 equals 16. That is how the CPU generates your numbers. It's off a binary code. And notice that they go up in increments. If you ever need to make your own table, or I should say they go up exponentially. 1 times 2 is 2. Well, it's not really exponentially. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. This is wrong. This outcome should have been 15. 8 plus 4 plus 2 plus 1 equals 15. But anyhow, if you do things that way, 1 times 2 is 2, 2 times 2 is 4, then you can come up with any single number in binary. It doesn't skip over any of them. Let me see what else is. I really can't think of any way to go in any more detail on that. Maybe I'll try to remember to post a supplemental binary YouTube video. Somebody else who's maybe explained it a few more times than me. But that is how binary works. So let me go over into this now. Change the name of this one too. I'm going to hand you guys both of these. I should have thought about this before I started the lecture, but I should give these to you guys for reference. So I'm going to change this to okay, so memory latches and computer components. This stuff isn't really that relevant for for coding. We just went over the binary stuff. This is what is important. There's several different types of gates. Those of you who've had me in the intro to media already know there's an AND gate, an OR gate, and a NOR gate, and those 3 gates can be used to create more complex gates leading up to a CPU. If you actually had one of these chips, you know what, I should just bring that up on images. They don't have very many pins to them. Okay, there's the schematic for it, but I want to show you what the actual physical pin looks like. They're all going to be schematics, aren't they? There they are. Okay, so these chips contain 4 AND gates or 4 OR gates. One of the pins is a ground, and one of the pins is for your positive 5 volts, because binary digits are actually at the electronic level. A plus 5 volts is a 1, and a 0 volts is, well, a ground is the 0. So the pins to your AND gate would be like this one would be your input, these 2 would be your inputs, and then this one would be your output. So you would have, the way the AND gate works, let me go back over here. I feel like I'm trying, bear with me, I'm trying to cram another career field of electronics engineering. I'm trying to mold that into programming and give you just enough understanding of it that you understand how these bitwise operands are going to work. So this is perfect. This right here, can I make this any bigger? Oh. Okay, so your AND gate right here, if you have two inputs of a 0, you have a 0. If you have a 0 here and a 1 here, you get a 0. A 1 here and a 0 here, you get a 0. The only way you're getting a 1 out of an AND gate is if you have two inputs of 1. The OR gate is the absolute opposite. If either of these have a 1, you get a 1. The only way you're getting a 0 is if both inputs are 0. If you get a 0 and a 1, 1. If you get a 1 and a 0, you get a 1, or a 1 and a 1, you get a 1. So if there's a plus 5 volts on either one of these, you get a plus 5 volts out, which represents your binary 1. This one, you need plus 5 here, plus 5 here to get the plus 5 here. If either of these is 0, then you get a 0 out. And I'm going to go a little bit more into detail on these gates, and then I am going to pause the lecture, take 5, and then I'll post another lecture right after this one. So I'm going to actually draw out, to the best of my ability, the AND gate, that's the AND gate, believe it or not, and then this one is going to be our OR gate. Okay, so if you have some voltage over here, that messed up. Okay, that's a plus sign. Where's my just free scrolling to my pencil tool should work? I know that's pathetic, but it's okay. So if you have plus 5 volts here, or if you have plus 5, change the color, plus 5 volts here or here, and this switch goes down, you'll have plus 5 volts out here. So that's basically the gates. If either of these are on, you get your voltage out. Now for the AND gate, if this gate's down and this gate's open, you still don't get your voltage out. Both of these gates have to be closed in order for your voltage to make it all the way through. Both of these would have to be flopped down and making contact. So that's a physical way of looking at how these chips work. And an inverter is very simple. The schematic symbol for it is just a triangle with a little thing, a little circle, and that just means if you put a 1 in, you're getting a 0 out, and same vice versa. So those are the three gates that make up every other gate, and they function off of plus 5 volts or ground, which represents binary 0s or 1s. So go ahead and let that digest if this is something you've never really messed with before, and we'll start a new lecture to actually get into the bitwise operands.